Okay, for this one, we have ABCD as a parallelogram. We want to find out what x is. So we've got AC is 3x squared plus x. So AC equals that long diameter. And then E was supposed to be listed here as the intersection of the two diagonals. And the theorem that we know about parallelograms is that diagonals bisect each other, which means that AE is equal to EC. So if EC equals negative 2x plus 10, then AC, that entire diagonal, is twice that, negative 4x plus 20. This gives us an equation with only one variable, so we can solve it. It does turn out that it's a quadratic equation, so let's get everything to one side. So that's going to give me 3x squared plus 5x minus 20 equals 0. We need to find out what x is. It's possible there's more than one value of x. We're looking at this. Based on these numbers, looks like it might be factorable. You could play around with it a little bit. There's not too many choices to try to factor it. It turns out that it's not factorable. So instead, you need to use the quadratic formula. Make sure you remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant. So it's going to be x equals negative 5 plus or minus square root of b squared is 25 minus 4 times 3 times negative 20 all over 2 times 3. That gives me negative 5 plus or minus square root of, well, this is 265 all over 6. Now, this is two answers. You might question, do both these answers work? It does turn out that both of them work. You might be a little bit concerned because one of them is negative, right? Negative 5 minus square root of 265 is a negative value. Well, that's okay, because when I plug them back in here, even though the x is negative, the values of the lengths are positive, and so that means that you don't get into any problems with those negatives. And so this is your correct answer, negative 5 plus square root of 265 over 6, and negative 5 minus square root of 265 all over 6.